Hello everybody, welcome to our series of videos about our program for AP Biology Grade 11. Today I have the best, biggest, strongest, most beautiful topic that we have in biology. It's actually one of the most complex if you think about it, which is the energy obtention in superior animals. So today I'm just not going to give you a big talk about this or that. I'm just going to summarize all the information in three big parts. The most important thing you need to remember for your evaluations, for your exams, is this set of information. The first one is mitochondria. The structure of the mitochondria. Be very clear about the structure of the mitochondria. That is absolutely crucial for you to know that mitochondria is the energy center of the energy plant of the cell. Next lesson is going to be about the structure of the mitochondria itself. So for today, I'm just telling you, check on the structure of mitochondria because that's going to help you on the long road. Number two, the numbers, the statistics. We can divide energy obtention in three big parts. Aerobic energy obtention in three big parts. The first one is decarboxylation, the second one oxidation, and the third one is phosphorylation. With the name, you can already guess what's this about. So decarboxylation is breaking down carbon. Oxidation is, of course, using oxygen in order to burn, to combust the subproducts of this breaking down of sugar. And the third one, phosphorylation, is the extraction of phosphate, ATP. That P is for phosphate. So this will give us an idea that the most energy that we can obtain is from from phosphate. So the third part for phosphorylation. So let's go real fast. This process is divided in three steps, and it's also divided in three parts. Outside of the mitochondria, inside of mitochondria in the matrix, and inside of the mitochondria in the cristae. Let's go part by part. Outside of the mitochondria will happen the decarboxylation. Decarboxylation will break down this molecule of sugar. This is called glycolysis. Glycolysis happens outside of the mitochondria. Of course, this goes way beyond, and I'm not going to go very deep into this, but for 7, 8 grades, normally I explain that the glucose molecule is way too big and way too complex to break it down inside. It's like if you have a big bed at home, and you don't. It's easier to take it, not armed, not totally built, and you have it into a box, and then just build it inside, get it together inside of your house. Way better. So our cells are extremely good for doing that. So they break down sugar outside, and then they take these two molecules of sugar, of pyruvic acid, and break them down and gather in. So the second step of this is the Link reaction, which is part of this will go into the Krebs cycle, and then will repeat itself for the Krebs cycle. Third step is the Krebs cycle, that is almost all together with the Link reaction, and the final and the most energetic part itself is the electron chain reaction or electron transport chain. Now, for the numbers, decarboxylation will give us 6 plus 4 plus 2, 12 carbon dioxide molecules, 4 from the Link reaction, 2 from the Link reaction, 4 from the Krebs cycle, and 6 from the ETC, electron transport chain. Oxidation will provide us with NADH. What is NADH? NADH is actually the carrier molecule of this hydrogen, and this hydrogen is the one that is going to provide the energy of the final reaction. So we have 2 in glycolysis, we have 2 in Link reaction, we have 6 in the Krebs cycle, and we have 10 in the electron transport chain. Remember those numbers, 2, 2, 6, 10, and that will give you a big help in your test, in your exams. Also, we also produce FADH. It's a very similar molecule that when F is available instead of N, it's used. Both have almost the same structure. One is dextrogerous, the other one is levogerous, but basically they work exactly the same. So we will have 2 FADH in the Krebs cycle and 2 FADH in the electron transport chain. Finally, the money, the dengue for our reaction, which is ATP. ATP is like the coin for our reaction. So these totals are absolutely necessary for you to remember. Beg your pardon. Every test that I've had the pleasure of grading in these years has included one question about the phosphorylation and how many ATPs we produce in each step of the way. If you remember these very specific numbers, this will give you an idea of the rest of the process. So remember this: glycolysis will produce 2. But Mr. Chris, I read in a book that it says 4. Yes, 4 total, 2 net. 4 total means that it produces 4, but it uses 2 to activate the reaction. You know what I'm saying? Like in thermodynamics, we know that no reaction is free and no reaction is perfect. This is no exception. We need energy to break down the initial part of sugar. So we produce 4, but the net result is 2. Link reaction doesn't produce ATP. The Krebs cycle itself. Normally we think that the Krebs cycle is the one that produces the most energy and it's like, wow, an explosion and everything. It is not. The Krebs cycle itself is just the preparation, the breaking down, the modification of the molecule. We're moving a molecule from 6 to 5 to 4 to 2 carbons in order to use it, to put it in a way that we can extract the most amount of energy. So in this case, we only have 2 ATPs. These are marginal ATPs. We don't really extract a lot of energy from this, but these will add up until the final number. Now, remember when I told you that we modify the structure of the sugar molecule? We break down, first we have 6, then we have 3, then we make it 4, then we make it 5, then we make it 3, so forth. This is not only done to obtain the energy, but to obtain NADH and FADH. Remember that these are the carriers of our molecules. These carriers will grab the hydrogens, and those hydrogens were going to be used for the final step of the way. The final step of the way is the electron transport chain. Remember this number as big as a house, 36 in ideal conditions. Sometimes it's less, but the maximum, the top, the perfect reaction should be 36 ATP. 36 plus 2 will give you 38 in ideal conditions. Sometimes it's not ideal, but most tests play with the idea of having perfect conditions, ideal laboratory conditions. We only have 1 minute, so the final thing that you need to remember is the final part of the process, the last part of the process, and this is, trust me, this is going to be in one of your tests. It's called the ATP synthesis. What is ATP synthesis? ATP synthesis is simply a molecule that we are going to use. It's an enzyme that will take ATP and will make it move. It will break it down. It will move the machinery in order to create, to have a proper use of this ATP. So all the details are in the lesson. So I'm not going to go into big detail for this. See you in lesson, and goodbye, my friends. Bye bye.